Hi, welcome to Social Research Insights. In my previous videos, I explained how to install two important software requirements to blink LED. That is number one, SDCC, which is Small Device C Compiler. We need this software in order to write the C programs to instruct which will help us to instruct the microcontroller to control the behavior of the output devices. In this case, we are using LED as output device, along with a couple of electronic components like resistor and jumper wires. And also explained how to install a peculiar software, which is actually the STM8 flash. The name of this software is STM8 flash, which is essentially a driver in order to make it possible for us to transfer the program, which is also known as the flashing the program or flash from the computer to the microcontroller through ST-Link V2. So now let us go ahead and construct our circuit, and later we'll try to write the C program. We are not going to write any program, but I will let you know how to get the program from online, because we already have a lot of code online, so we need not worry about writing the programs. So once we get that C program, then I will let you know how to flash that program to the microcontroller and cause the output device, in this case LED, to act as intended. Okay, now I did a circuit. So we already had computed the capacity of the resistor that we need in order to make this circuit possible. I have two devices apart from the STM8 chip or microcontroller board, and as you see that the LED has two legs. One is a short leg, the other one is a lengthy leg, and the lengthy leg is an anode which need to go to the pin that which we are intending to program. So the anode of the LED is connected to the resistor, and the resistor goes to a jumper wire, and that jumper wire ultimately ends in the pin number 3. I don't know whether you are able to see or not. There is a letter A3 there, and you can also see the jumper wire, and the jumper wire goes to the resistor, and the resistor ends in connecting with the anode part of the LED, and the cathode goes to the ground, and the ground is connected again to the ground of the STM8. So both ground and the pin that which we are intended to program, both of them are connected to two legs of the LED. So this is precisely the circuit that I would like to make in order to program the STM8. Now we finished constructing our circuit, and we also have our software ready. We installed SDCC, which is a C compiler, so which helps us to compile the C programs, and we also have STM8 flash that helps us to flash the compiled code, which is in the format of IHX, which stands for Intel hex file. So after compiling the C program, we'll get the hex file, and this hex file need to be flashed or transferred. In informal language, we will be transferring that program from the computer to the microcontroller with the help of ST-Link V2. And for that we need to write a C program. I'm not going to write the program. These programs are all there online already. I'm just going to show you a place from where you can download 3 important files. That is, number 1, a C program to blink the LED, and a header file, C header file, to that which helps to compile the C code, and another one is UART. That is very important for the programmer. So what is the programmer that we are using here? ST-Link V2. Now go to the same repository that we from where we had downloaded our STM8 flash earlier, and now this time you go to the other repository, SDCC examples and STM8. So these are the files that we require to compile the C program, and here we have a header file, STM8LH. This program is very much important because this file has all those functions that are very much necessary in order to convert a C file into the hex file. And this is UART, Universal Asynchronous Receive Transmit file, written in C language, and this is Blinky, a file in which there is a C code that really helps us to blink the LED, and we have a make file, and this make file is a setup file, a bash script file that which will help us to compile the C program into the hex file. A hex file is actually a file in which there is a machine level code that communicates to the chip as what to do with the output devices. Now, so let us copy this and go back to the terminal. I think I already have this. I am in the project directory. You can see that STM8-DEV. This is the directory which we created earlier. Let me see. I already have those files, so let me first remove them. SDCC example. Oh my god. Okay, so it is telling me that I don't have sufficient sudo rm or f sdcc. Oh my god. Okay, now we got rid of one file, and that is actually a backup file. You don't worry, you might be confusing that why did I have the other same file. It is actually a backup file. I just wanted to keep it here in case if anything happened to my original C code. So now sudo git clone, copy paste. Now this is how your computer will try to download the code. Now test again. You will be having that SDCC example file, and this is the file which we had downloaded from this repository. Okay, so please be cautious. And now let us open that file, cd sdcc examples, in which you must be having some files. So these are the files which we need in order to compile the C program. So let us get into this C file, I mean the code file, and let us see what is there inside that. Sudo nano blinky. I like nano much. So now this is the code that we have inside the C the file in which there is C program. So here this is actually the header file, STM8LS, but we are not using the STM8L, we are using the STM8S, but it doesn't matter. The code is, the functions are same whether it is L or that is one of the advantages of using Unix. And we have the main function in which there is an integer declared. It is a D, and this integer helps us to delay
to create the delay in the program while blinking the LED. And this is actually the port E. The port E's 7th pin is enabled. I mean, the DDR stands for the data direction register, and the 7th pin of the data direction register is assigned. 7th pin of the port E is declared as the output pin. So now we are not going to have the 7 pins in our STM8. Perhaps if we are working with STM32 or Atmega AVR processor, then possibly we can work with the 8-bit pin. But whereas in this STM8 is a very sleek and slender module where we don't have the 8 pins available. The maximum we have 6 pins. So what we do, we'll try to change this program, and I will take A port instead of E port and declare all the pins as output pins. So, and I did not talk about this CR1. It is actually the control register. The function of the control register is to do several actions and several functions, and especially it will try to control the CPU behavior. I mean, in this context, the control register try to help us to change the mode of the pin. So here the mode of the pin is output, and the control register in this context will try to act altering the mode of the pin of the port A. And now let us make the same change here, and ODR is the output data rate, and this is actually the symbol. This is the notation which we need to use in order to switch the. It is a special gate used in C programming language. I didn't talk much about all these gates and functions. Perhaps I will try to make a few more tutorials as how to write the C program, but the purpose of this tutorial is not to explain the internals of in and out of the C program. This is actually the XOR gate, the extended OR gate, and it has a special and peculiar behavior, so that if the incoming signal is 1 and the present state is 0, then the output will be 1. And if the incoming signal is 1 active and the present state is 1, which means the LED is on, then the outcome will be 0, which means off. So that way it helps us. This XOR gate helps us to alter the behavior on and off for a particular period of time with a delay. Okay, so now we also have to make this change FF, and after that this is a for loop. As I said, D is an integer, just a constant, and which is going to repeat for a particular number of times. Actually here the delay, we just roughly would like to delay for 3 seconds or 3 milliseconds, whatever it is. And this depends on the internal clock of the STM8 module. And this is precisely the C code. We have declared the output mode, and we are trying to control the output mode. And after that, we used a XOR gate in order to work with our STM8. So now, save this and get out of the code. And we just have to use a particular go back, or you need not go back. You can go to the CD STM8 flash, now ls. So this is the file, script file, which helps us to flash the program to the microcontroller. Now execute the code. Sudo we need, because we need the root privileges to run this code. STM flash, STM8 STM flash, say the programmer STM link v2 p part, which stands for part STM8 S103, right, go back to the previous folder SDCC, just press tab and blink key. So we don't have, actually, I'm sorry, I could have told you that we actually did not compile the program. So let's go back, ls cd sdcc, yes, ls. So we did not compile, actually, we only verified what is there in the C file. Now what we need to do, there is a small glitch in this make file. So when you compile the C program, it will try to give you an error saying that something is missing. So in order to, I'm going to tell you what is that missing. So let us verify what is there in the make file. Sudo nano make file. So this is actually the make file. I will try to talk about the parts of, the components of this make file later. It is very simple code. You need not worry what is there in the here. Actually, there is a small snag in this code. Let us delete this sp_test ihx. Actually, we don't have that file in our. We'll be giving only these two files. We'll be flashing only these two. We need only these two files in order to flash the program to the microcontroller. That is number one, blinky.ihx and uart ihx. That's all. We don't have anything other than that in our directory. So let us not have anything extra. While compiling, we may run down to some errors. So save, exit. Now sudo make. So this is what all you need to do. That's all. So now let us go back and see. You got all those hell lot of ingredients to flash this C program. So this is what exactly we are trying to create, blinky ihx. This is actually the file in which there is a mission level program which we actually need in order to communicate to the microcontroller that what it is expected to do. Okay, now we need to go back to the STM8 flash. So here we got to give that command. I think I should be having that command in my history. Let me see, I don't know, because I closer to this. Yeah. So this is actually I was trying to talk with. So this is actually STM8 flash. Here in this directory is actually a script file which we generated by simply executing a peculiar command called so somewhere we should be having that. So then blinky. I think we compiled this. We configured this as actually make file. Sudo make. So these are all the files that earlier, I think not in this part actually. Earlier I told you how to compile this STM8 flash which we downloaded from the repository, and this file is actually the resultant this output of that activity. Now, so the STM8 flash is a script file, and we are trying to communicate to the microcontroller. C stand for the component, P stand for the part, and we have ST-link v2 programmer, and we are trying to work with the STM8 S103F3, and we are telling the computer the programmer to write the file, and the file is blinky.ihx, which is a hex file and which is there in this directory. So we just have to After this we just have to press OK. So the device is not there, so let me connect that divide.
So I'm going to connect this STM8 to the computer, and let's flash the program to the microcontroller now.
So we connected our circuit to the computer. Now let's execute this. Yes.
So now you can see that LED is blinking. So this way we can program the output devices in this.
So thanks for watching my video. If you really like, please press like, subscribe to the YouTube channel, and stay tuned for the new content.